Okay, those who are here, go mark your attendance. Today's lab will be actually very fast because there's only 2 tests to do. Okay, for those who are ready, you can open up your R Studio first. Okay, let's wait for a few more minutes for the rest to come in. We will start at 1:05. So if you need to go to toilet, you can go ahead. Okay, Xavier, can you ask the rest to come in first?
Okay.
Okay, so let's get started. Okay, so we are only going to do 2 tests today. Your Wilcoxon rank sums test and Wilcoxon sign ranks test. Okay, so let's do on the rank sum stats first. Can somebody tell me what is the parametric equivalent of rank sum stats? Let's see, Jordan.
Parametric. Uh, Wait, give me a moment.
Okay,
It's is it a parametric? Independent t-test.
independent t-test, yeah, also known as your two samples t-test. So let's look at how it looks like. So you assuming that you have drug A and drug B, um, whether it will affect the urine output, so the urine volume of how many milliliters per day. So you have two sets of patients. Okay, one set of patient given one drug A, one set of patient given drug B. You want to test whether is the average of the urine output equal. That means now hypothesis will be um, the average of urine output from drug A is the same as the average of urine output in drug B. Okay, so how do you actually get the test data? We give you a file already. So let's look at this file, your MWU. Open up in an Excel to look at see how this file looks like. Okay, because it's not your normal way of doing things. Okay, you open up this file, and or you can just look at my file. Make sure that you have the file there first. Okay, so you see, you have a patient ID, your urine output, and the drug. So A and B is all listed here. Okay, it is not the regular way which we do things. If you do your t-test, you will do your drug A, then drug B. Okay, then you have two columns of data. Okay. For R, we put everything together. Okay, so this is how R does things. So let's get to it first. Okay, don't save. Now, okay, let's go to R. Okay, so make sure that you change the working directory as usual. Course materials, VDA, lab menus. Anyway, today's the last one. Okay, so why not you load up this MWU, import the data set. Okay, it will ask you probably see whether you need to install anything or not. If it doesn't install anything, it's fine. Okay, so you got the data there. Okay, then you import. Okay, once you have import, then you can raise up your hands. Once you're done importing, raise up your hands so we know that you're there. Okay, remember to raise up your hands once you are finished importing, so you can go on.
Sorry, you can show how to import again.
Just click import dataset, then import. Yeah, this button import.
Okay, thanks.
Now for some of you, you may have to install some stuff, just install. Okay, if you don't have this read R package, then you have to install it. So that may take a little while. Saki and Jingru, are you done already or what?
I'm waiting for the downloading for the installing.
Saki?
Yeah, done.
Okay. So Jingru, once you're done, then raise your hand so you can continue.
Okay. Yeah, it's okay.
Okay, done already? Okay. All right. So what we are going to do is, let's look at the how do you actually run the test. It's a Wilcoxon test, X versus Y. Okay, the data and then the alternative. So what does it mean is, this is the function that we want to use. Okay, we want to test urine against drug. So drug is the categorical variable. We want to separate based on drug. Okay, so we take this command, paste it here. Okay, make sure your Wilcoxon doesn't have the OM behind. Then how does it know which data to take? Because your data variable, it uses the MWU, okay, two-sided test. So once you have that, then you have your answer. Okay, that's how you run your Wilcoxon rank sums test. Okay. So this is the p-value. It only tells you what is the alternate hypothesis. The alternate hypothesis means that it's not equal to 0. It means that there's a difference in the two data sets. So this is what you get from your result here. Okay, don't really quite bother about the warning message. That means your Wilcoxon rank sums test, your W statistic is 15. Okay, see if you can see if you can get the answer that you have. That I have. If you get the answer, then can you accept or reject the null hypothesis? So, Bernice, do you accept or reject the null hypothesis?
Don't accept.
Don't accept the null hypothesis means you reject the null hypothesis.
Yeah.
But is this p-value more than or less than 5%?
More than.
More than 5%, you accept or reject null hypothesis.
Accept.
Yeah, lor. Accept lor. Then why you say reject?
Sorry.
Okay. So accept the null hypothesis means that there is no difference between drug A and drug B in terms of urine output as far as Wilcoxon rank sums test is concerned. Okay. Now, another way of doing it is this. Okay, let me show you another way. So, for example, you don't have the data. Okay, you can actually take. So I remove this data. Another alternative way of running the command is this. Okay? You put your MWU $, MWU $. That means that you don't need this data variable. Okay, it will give you the same answer as well. Okay, it's taking the data MWU, the urine from it, and versus the drug. Okay, so there are two ways of doing it. So it depends on which version you want. Okay, it gives you the same identical output. Okay. So this is all that is for your Wilcoxon test. Any problem? Okay. For those who get the same answer as what I have, you can raise your hand so you can go on. Trevor, Xavier, Bernice, okay. Bernice, are you all there? Are you there? Where is she? Okay, you can put down your hands now. So let's continue. Okay, so our next test we are going to do is um okay, you can actually, because there's a tie, okay, so computation, it doesn't have a tie. What you can do is you can actually put the data in yourself, okay, but it's a bit more tedious. Okay, so you can actually write the data. If you do not have the raw data, that means you do not have the Excel file, the Excel file that we have, you can put the raw data in. So you just put the data, let's say drug A. So this is the data. Say this is the data for drug A. That means all your values for drug A. Okay. And then you have the next one, which is the values for drug B. You also can run the test this way. So all these values, instead of you have it in your Excel file, you can type it in yourself. You can type out all these data yourself. So you type in A and then type in B. Okay, so that's what it means. After that, you just do a Wilcoxon test. Of drug A against drug B and have two-tail hypothesis, you also get the same result. Okay. This is, yeah, this is one. Try this out and see whether do you get the same result as what I have. Okay, this is for you to actually type in the data in yourself. Okay, but we seldom use this method because you cannot save the data. Once you do a test, the data, after you close, the data is gone. Okay, so try this out. If you are okay, if you are done with it, then raise your hands again. So we have done two things. One is you type in data in R yourself. One is to prepare an Excel file, and then you import the data. So and zoom. All right. Okay, so you can put down your hands now. Okay, so we are done with your Wilcoxon rank sum stats. Okay, so the next one that we are going to do is your science rank stats. Why is Wenjie leaving? Okay, Ryan. So science rank test, what is the parametric equivalent for it?
Is it the PET T test?
Yeah, it's PET test, correct. So normally you have before and after. Okay. So how do you do it? It's very similar. We take the before data. So we have the before data and after data. Okay. Before drug C and after drug C. So it's basically what am I doing? Okay. So we kind of key in the data in 4, 6, 5, and so on. But it must be in order, because 4 and 4 it will minus off. 6 and 3 will minus off, and so on. So you key in the data, it must be you key in based on the order. Okay, so far. Okay, so let's key in the data first. So this is before. After. Okay. Again, I have to stress that make sure that your data is keyed in properly. It must have the same number, because it's treated as the first four and the after 4, it is the same person. Okay. Then to run your science rank test, what you really do is to run your Wilcoxon test, but you need to add another variable, okay, which is the last one, paired equals true. When you have paired equals true, it will run your science rank test. Otherwise, it will run a rank sum test. That's the only difference. Okay. So let's enter, and that gives you your result. Okay. So it runs a science rank test, your statistic, and the p-value. So once you get this data, then you raise your hand of this result. Okay, so Jolene, based on the p-value, do you accept or reject the null hypothesis?
Accept.
Accept the null hypothesis, right? Okay, so accept the null hypothesis as there's no difference. Okay, so I'll show you again. If you forget this paired equals to t, then what happens is you run a rank sums test. Okay, please do not make this error. Sign rank test and rank sum test using the same function, function, but it's whether you add this paired equals to t or not. That's all. Okay, so this is your sign rank test. This is your rank sum test. Okay, please take note of this. Okay. All right, so you can put down your hands. Now, similarly, we can also put the data inside an Excel spreadsheet. So you can actually copy this data and put inside an Excel spreadsheet. So I already put it inside my Excel. I call it drug, D-R-U-G. And see whether can you run it using the Excel version. That means you import from Excel, import the file, and you run the rank sum sets. So you're patient before, after. Okay. Then you save it. So let me try. So I have my drug. Import the data set. Okay. So after I import my data set, then I run my test. Okay. Drop before. See whether can you get the same result. So I use this structure. The drug is the data, column before and column after. Okay, so if you manage to do this, if you manage to achieve this by importing your data and then run your Wilcoxon size rank test, please raise up your hands. Okay, how about the rest? Damien, Jordan, yeah, try it out. Make sure you get the same answer.
Hi, Jordan here.
Yeah,
For mine, they write object drugs not found.
object drug not found. Do you have
Yeah.
this data here?
Yeah. I went to put on an Excel file, then I import.
Okay, object drug not found. Okay, I think you better show me your screen. I have no idea what has happened. Okay,
Okay.
show me your screen.
Uh,
Share screen ah.
yeah, am I doing it?
Not yet.
Okay, yeah.
You are seeing your
Okay.
fonts instead.
Okay. I think I'm done.
Okay. Uh, yeah. See, um, D, capital D,
Oh, okay, my bad.
and yeah, capital D, and make sure that you have your S. You still have an error, right? Okay, because you see, your before, um, okay, you go to Excel file, don't have the word before drug C. Make sure it's one whole word, otherwise you cannot handle it.
Wait, okay, I go to my Excel file then. Sorry.
Go to Excel file,
Mm-hmm.
change the heading before drug C to just before and after.
Oh,
Yeah, then you re-import the whole thing again. Yeah, correct. Okay, so now, yep, capital D, capital D. Okay, should work already. Before, how come yours doesn't work? Okay, after, okay, show me your Excel file. No, you have to share your whole screen, otherwise you can't see your Excel file.
Okay. Okay.
See, don't, okay, your row number 1 and row number 2, throw away your row number 1 and row number 2.
This two.
Yes, yeah. Delete first. Okay. No, you delete the whole row, delete the entire row. Yes, okay. Then you insert row above number 1. Okay. Then A, you type ID, will do ID or patient ID, up to you. Okay. Before, BEFORE, after. Okay, then you save this and then redo the whole thing in R.
Okay.
Because just now what it tried to take is your before and after is the second row, so you will not recognize it. Okay, so go to R. Okay, so you re-import again.
Yeah, I just re-imported.
Okay, so does it work?
Oh yeah, it does.
Okay,
It does,
hello.
I think.
So that's it.
Yeah.
Okay,
Okay,
then I
thank
share the
you.
screen. Saki, are you okay?
Oh yeah.
Okay. So if actually that is all for today. Any problem? Yeah, that's all for today. You can get this result. That's all only the 2 tests you need to do. Okay. What that error message is because what happened is in R, your Wilcoxon science strength test doesn't deal with the ties. That means the ties is this. Doesn't deal with the ties very well. Okay, but it still gives you the same result. Similar result, like in the sense. Just that when you never deal with the ties, right, you have to get a different calculate from a different critical value table. Okay. The conclusion is still the same. Okay, because the p-value will be affected according to this. So the v statistic will be different. Okay, but otherwise it's fine. Okay, so any other questions before we finish off your whole module? This is the last time already, last day. You mark your attendance. Yeah, today this is the shortest lesson. Any problem so far? You can put down your hands. Any problem? You can ask now. Okay, if not, then you can all go and have your lunch already. If you have not eaten, go and eat now. That's all for today.
Thank you, Joe.
Bye bye.
Thank you, Chair.
Thank you.
No problem.
Thank you.
Okay, see you soon.